Welcome, ladies and gentlemen, to another presentation by me, and here we're going to describe how do you balance a chemical, which also means how do you balance a chemical equation, and yeah. So, first let's get to the terminology, and then we're going to go into the actual equations, and we're going to balance them in the next slide. First, what are coefficients? Coefficients are small whole numbers that appear in front of the formula. These can be altered to balance the equation. This is what we're going to be tweaking in order to balance our equations. We can't actually touch anything else, so yeah, these are going to be our prime focus during the balancing. Reactants are all the materials present at the start of the reaction. Reactants are written on the left-hand side of the equation arrow. Products are the materials that are formed at the end of the equation. They are written on the right-hand side of the equation arrow. And subscripts are the small lowercase numbers that help identify the molecules. Subscripts cannot be changed when balancing chemical equations. This is a big rule, so you can't really change the subscripts because, well, if you change the subscripts, you change the identity of the molecule or element you're dealing with. So if, for example, there was H2O and you decided to change the 2 to a 4, then it's the H4O, and that's no longer water. And that's a problem. So without further ado, let's go into the balancing. So you see there, and that reaction occurs when propane, the fuel that is generally used to produce heat in furnaces, reacts with oxygen to produce water and carbon dioxide. And we're going to balance that. One rule to look out for is to remember to always leave hydrogen and oxygen for last. So when we look at that, the first thing we notice is that carbon is there, other than the oxygen and the hydrogen. And on the reactant side, we have 3 carbon atoms. On the product sides, we have only 1. So naturally, we add a 3 to the carbon dioxide that is on the product side. After that, we notice, well, we can go either way right now. We can analyze the hydrogen or we can analyze the oxygen. But for purpose sake, let's look at the first reactant, and we notice that there's 8 hydrogens on the reactant side. In order to balance that, we're going to put a 4 next to that H2O. You can see that there's H2, so in order to make that into 8 hydrogen atoms, we're going to put a 4 there, which is 4 times 2 equals 8. This way we have 8 hydrogens on both sides. Now let's look if there's anything else to balance. We notice that there's only 2 oxygens on the reactant side, whereas we just times by 4, so we have 4 times 1, which is 4 oxygen atoms. Additionally, the 3 times 2, which is 3 times O2, which is 6 oxygen atoms. So we have basically 10 oxygen atoms on the product side. In order to balance that, we're going to put a 5 next to the O2 because that will make it 10 oxygen atoms on the reactant side. The reactant side as well. And there, you have it. It is balanced, and there is nothing else that needs to be added. This abides the law of conservation of mass, and, well, it's time to move on. Here are a set of 3 different equations. They start from easy and generally get tougher, and we're going to tackle each one of them and show how it's done. The very first one, well, we just discussed the rule that you have to leave hydrogen and oxygen for last, but as you can see, in the very first equation, the only things that are there are hydrogen and oxygen. So you can go either way. Once again, you can choose hydrogen or oxygen. For starters, let's just analyze what's missing. Well, we have 1 oxygen on the product side, but 2 oxygens on the reactant side. In order to balance that, we're going to put 2 in front of the H2O. That gives us 2 oxygens on the product sides and 2 oxygens on the reactant side. But now notice that we have just times the H2 by 2, making it 4 hydrogens on the product sides and only 2 hydrogens on the reactant sides. So we're going to add another 2 there, and this balances the equation. We can also add a 1 next to the O2, but this is generally not done, as in, when you're dealing with quadratic equations in math, or when you're dealing with linear equations in math, you generally just don't put that 1 in front of the x, so we're going to drop that as well. The next one's a bit tougher, but not really. So we're going to start this by noticing what's missing. I told you that you should start with the atoms that are not oxygen and hydrogen, but we should notice that oxygen is actually the only atom that is not balanced in this equation, because we have 3 oxygens on the reactant sides and only 2 oxygens on the product side. Now, in this situation, there's a very interesting thing that happens. There comes a 3 next to the O2, and we put a 2 next to the O3. So we basically just flip-flop the numbers. In other words, we just made 2 times O3, which gives us 6 oxygen atoms on the reactant sides, and 3 times O2, which gives us, of course, 6 atoms on the product side as well. But because we did this, we kind of screwed up the system in terms of potassium and chlorine, so we have to balance that too. We notice that there's 2 potassiums and 2 chlorines on the reactant side, so we put another 2 on the other side as well, balancing the equation. Last but not least, we have this big guy down below, but I know it looks scary, but it's actually not. As long as you know the basic algebra, it should be easy. So the first thing we can do here is notice that the sulfate is in brackets and it's multiplied by 3 by another subscript. So in order to balance the sulfate, we're going to put another 3 on the other side. After we did that, we are going to see what else we can fix. We just timed calcium sulfate by 3, so the calcium atoms are 3 on the product side. In order to balance that, we're going to have to put 3 next to the calcium hydroxide on the reactant side. Now that we did that, is there anything left to balance? So we have 3 calciums on both sides. We have 3 sulfates on both sides. Aluminium is currently not balanced, as you can see, because aluminium is 2 on the reactant sides, but only 1 on the product sides. And as for the hydroxide, we notice that there are 6 hydroxides. 6 hydroxides on the reactant sides and 3 hydroxides on the product side. So we can actually solve this issue very quickly by just putting a 2 next to the aluminium hydroxide. That settles everything, I think. There's nothing that needs to be put in front of the aluminium sulfate because that already fits into the equation. We have 2 aluminiums on the reactant sides, 2 aluminiums on the product side, 3 sulfates on the reactant sides, 3 sulfates on the product sides, 3 calciums on the reactant sides, 3 calciums on the product side, and finally we just balance the hydroxides, and that gives us 3 hydroxides, 6 hydroxides on the reactant sides, and 6 hydroxides on the product side. So that should settle everything. And there's others too, but generally they don't get harder than this. So they should have explained everything you need to know about balancing equations. Well, generally. So now there's also another method for solving these, and that's called the algebraic method. Personally, I prefer the traditional, but some people prefer the algebraic method as well, so we're going to discuss that as well. So you notice that we have an equation. Now in the algebraic method, you basically solve for x. I mean, that's what algebra deals with, and you're going to be solving for different unknown variables. So you're just going to put unknown variables in front of all the molecules and atoms we have. So we're going to put an A in front of I'm going to put A, B, C, and D. Now, we notice that A must equal C. A must equal C because phosphorus has to be equal on both sides. So C is in front of, as you can see, a phosphorus on the product sides, and phosphorus on the reactant side would be A. So A must equal C under all circumstances. Next, we notice that 5A must equal D, and that is because the chlorine has a subscript of 5. That means it is multiplied by 5, whereas on the product side, there's only 1 chlorine with no subscript. So basically, as you notice, that all these equals and relations that we're coming up with algebraically, that is based on the subscripts. So that's something to be watched out for more in the algebraic method than in the traditional method. So based on the subscripts, we're going to come up with another identity, I would suppose, or just relation. We notice that there is H with a subscript of 2, making it H2 on the reactant side, and as for on the product sides, we have H3 with a subscript of 3, and a single H, so 2B must equal 3C plus D. And finally, let's do something for the oxygens. For the oxygens, we just noticed that there is a single oxygen next to B, and there is, of course, 4 oxygen with a subscript of 4 next to C. These are, well, relations that we came up with, and algebraically you can solve for the unknowns, which will eventually give you the fact that, first of all, well, we noticed that, well, first of all, let's just put 1 for A. And basically, as we put 1 for A, we can always correct that, and we're going to start off with putting 1 for A. And then, if we have put 1 for A, then C must be the same as A. So you would put 1 for C as well. Now, 5A equals D. 5 times 1 is 5. So we put 5 in front of D, or instead of D. And the only thing that's left, of course, in that situation is B. And that would be 3C plus D. 3C equals 1 and plus D. So we just put it... So yeah, 3C equals 3 times 1, which is 3. And D would be 5. 3 plus 5 equals 8. But notice that it's 2B equals 3C plus D, so you divide that answer by 2, getting a 4. And that gives us this equation. And it is completely balanced. It took, well, in my opinion, it took longer to solve than the traditional method, but if you like this method or if you prefer it, you can always try it instead. And finally, let's discuss why do we balance. The law of conservation of mass states that mass cannot be created or destroyed, only transferred. And in all reactions, the number of atoms has to stay the same to abide this rule. Unless, of course, you're breaking up an atom, but even then, the mass has to stay the same because mass cannot be created or destroyed. If the reactants are more than the products, that means that mass has been destroyed. Alternatively, if the products are more than the reactants, mass has been created. So this cannot happen. And this is probably the biggest rule to watch out for. The next one probably be to never change the subscripts. But yeah, just watch out for this. And that concludes my presentation. Here are the references. You'll notice that my third reference is actually a book. And, well, yeah, and the 2 images I got from those sites. I didn't actually use a lot of images in this presentation, but oh well. And that concludes the presentation. Thank you for watching. The end.